Quick introduction. My name is Dana Morse. I'm with Texas Instruments. I taught in the classroom for 10 years. I taught algebra, geometry, calculus, and special ed math. So, special ed math is really near and dear to my heart. I was tasked with getting students confidence for challenging the New York State Math Regents exams. The students often felt like math was their worst subject. I would come at it with an approach that this technology, if used the right way, could really build confidence, and students who normally would shut down in a math classroom would actually try to succeed in the math classroom. Okay, so my email address right there, dmorse@ti.com. Okay, so the agenda. First things first, I love Christmas, so I'm going to make Christmas, anytime you watch this video, resources for educators and students, tips for the TI-84 plus CE technology, and if we have time, go into some state exams, especially Algebra 1, on how I can use this calculator in the Regents exam environment. Okay, so math teachers, you guys have lots of problems, and I have solutions. You already showed me that you had your 84 plus CE in hand, but I am going to be using software, especially in this day and age where you have to do distance learning. Every teacher that uses a TI graphing calculator must have access to the software. I am making the software free. If you can hear my voice, all you have to do is email me, dmorse@ti.com. Your school may have licenses, but we're about to get to the holiday season, and there's a good chance we could have work from home days. And some teachers don't have access from their home computers. So if you just need it for home, let me know. 84 plus CE, some people use Inspire, and some middle school teachers use the scientific model. Just contact me. If your school does not have enough calculators to send home with the students, and you do have access to Chromebooks, until July 15th of 2021, TI has made their beta app for Chromebooks free. And TI does not collect any user information. 100% across the board free, and we really don't even know how many users are using the app. So again, take advantage of that. If you don't have Chromebooks, but students don't have a calculator, but they need access, the educational dealers have made a 365-day license for as low as about $13. So it's an affordable solution, a way to get students hands on a graphing calculator. Now, do you use Zoom for your meetings or for your lessons? Awesome.
Yes.
Awesome. So I'll show how you can use Zoom with students who might not have a graphing calculator, and they can still get access to it. Okay. What have I been doing since March, since COVID broke out? I have taken the time that I would usually be traveling to schools and doing this meeting face-to-face. I made a YouTube channel where I've done tech tip videos on the 84 plus CE, on the Inspire, on coding, on breaking down Regents exams. I have well over 60 videos there, ranging from 2 minutes to an hour long in length, depending on your attention span and how much screen time you want to give me. You have your channel ready to go from a teacher's perspective, for a teacher and student's perspective. This is the software, the TI SmartView CE for the TI-84 Plus family. Now, if somebody were to be watching this after this recording and they don't have the CE, what's great about the software is you do have the ability to change between the models. Sometimes kids have hand-me-downs in their family, and the 84 Plus was the cutting-edge technology. You can just simply change it to the TI-84 Plus. Okay? You haven't touched a graphing calculator in quite some time. Hopefully you found the on button. That's in the bottom left-hand corner. And what's great about this...
That was easy.
That was easy. That's like the Staples "that was easy" button. Okay. The on button glows red. That's what's great about the distance learning with this software, is that whatever button I press, it will glow red for the student. So it's monkey see, monkey do. Not calling any students a monkey, but it's follow me. Now, you had said maybe you use Zoom and maybe the kids don't have access to a graphing calculator. In a Zoom meeting, if you're the host, there is an option called remote control. So, Jennifer, I'm going to select you, and on your screen right now, it should say that the host has granted you access to control my screen. Maybe you have to click someplace on the screen, but then when you move your mouse, look at my hands, people that can see the video. I'm not touching it. This is all you running the show. So if you're doing distance learning and a student doesn't have access to this software or a handheld, if you make office hours, if you can get the kids to log on, you can actually pass the ball to them so that they can take control. Now, like any person who has control, I want it back. So I believe I took it back from you. Yes, okay. So I'm back in the power. One of the first things I showed students when I had the graphing calculator was this. -3 squared. And I hit the x squared to square the base number. Now, years and years of middle school taught us that a negative times a negative yields a positive. But when our students press enter, they see this result of -9. So everything their middle school teachers taught them goes out the door. Because they're going to believe whatever the calculator tells them. Right? I thought this was an easy fix. I'll just tell the kids to use parentheses. Well, this is what my students would do. And when they press enter, they still got the same answer. And I go over to them and say you had to use parentheses, and they'd show me that they did. Little did I know it's all about where you put the parentheses. So they should have only encapsulated the -3 and squared the entire quantity to get the +9. That's the outcome we were hoping for. So how can I avoid these types of conceptual mistakes? With this little guy above the on button, STOW. It's short for store. It is the best button on this graphing calculator. Here's how I used it. -3, store, and you see a little arrow pop up on your screen. And then we have the built-in variable x, t, theta, n. I press that one, and I store -3 into the variable x. I press enter, and I see -3. That's not really the bells and whistles. Here's where it comes into play. If I put x on the next line, and then hit the x squared key to square it, and then press enter, I get the entire quantity squared. Okay? So step 1, showing the need for this to alleviate, or to get rid of the need for, eliminate the need for parentheses. Some kids don't even need this. They know they don't even have to check it. Okay? The next step. X times X. If you work with Algebra 1 students, kids who doubt their math skills, you're going to get 2 answers when you ask this question in class. We know the answer should be x squared. What's the other answer kids are going to say? 2x, right? You can't press enter and have it spit out 2x over here. But we are preparing students, especially in New York State, to take a math test. It says it right here. That's how I point it out to students. Math test. So if I want to access the test feature, it's in blue. I first press second, and then the math button to access test. The equal sign is right there in our test menu, along with all the inequalities. I can press enter right now, and that will select the equal sign. Students can type in what they think it's equal to. We know kids who struggle in math are also afraid to raise their hand and call themselves out, point themselves out that they need help. This says x times x equals 2x. I stored -3 into x. So it's really doing -3 times -3, which we know is 9. Is that equivalent to 2 times -3, which is -6? We know that's not true. Look at what the calculator does. It gives us an output of 0. The way I tell the students what that means is that it says you got 0 points on this question. You got it wrong. A cool feature on the 84 technology is that I can press the up arrow and I can scroll into the history on my graphing calculator. I press the up arrow again and you can see that it's highlighting what I just typed in. If I press enter, it performs a copy and paste. I can now use my arrow to back arrow, change 2x to be x squared, and when I press enter, the output is now a 1, which means you earned a point. You got a credit. You got it right. Computers speak in binary code. 1 for yes, 0 for no on the graphing calculator. This is communicating with the user, and it's just using the math based on what they stored in for x. -3 times -3 equals -3 squared. That is true. This one feature alone is the best feature on the graphing calculator when it comes to building math confidence and assessments. Doing well on assessments. Let's go even further with it. Now remember, I can just put in x and hit enter and see the value that's stored in. 2 times the quantity x plus 5. Distributive property. I've seen it many times. Kids are so excited to multiply the 2 times x that they forget about the plus 5. Again, math test. Second math, choose the equal sign, and you set it equal to what you attained by hand. 2x plus 10. When I press enter, I get that 1. It confirms it for the student. Let's kick it up a notch. X squared minus 9. Difference of 2 squares, and I'm now asking the students to factor on the graphing calculator. Second, math, the math test feature, equal sign, open parentheses, x plus 3. Close parentheses, open another parentheses, x minus, now we should say 3, difference of 2 squares. This student doesn't remember that rule and puts in x minus 9. What value did we put in for x? -3. -3, when substituted into x plus 3, yields a 0 right here. 0 times anything is 0. 0 equals 0. That's why we got this false positive. We have to be careful. If we're going to use this store feature, we must avoid integers. So instead, all of my students started with 12.3. The arrow on the store button is pointing right across the keypad. 12.3 is an arbitrary value, non-integer. I store it to begin my assessment into x. This anomaly will never happen with 12.3 stored in for x. I up arrow, press enter to copy and paste, edit, and if it's executed after 12.3 has been stored in for x, I get the true outcome that this is factored properly. Okay? This storing and test feature can check so much on the New York State exam. I'm going to resize my software and open up a state exam sample. Okay. The expression w to the fourth minus 36 is equivalent to June 1st, 2019. Well, I would do 12.3 store, and then we have to break out our bifocal lenses to find the green letters. W is on top of the minus button. So if I press alpha minus to get the W to appear, and then press enter, I get the 12.3 stored into W. I type in the problem as it was given. W raised to the fourth. Be careful. My exponent is where my cursor is. I have to right arrow once to get out of there. Minus 36. Math test time. Second math. Choose the equal sign. Now, students who struggle have a fighting chance. I'm going to go with W squared plus 6, close parentheses, open parentheses, W squared minus 6. This is answer 4. Difference of two squares, and I get the confirmation. That's the first question on the state exam. I already know that I'm starting off on a good foot. You'll see time and time again these equivalent to type problems can easily be handled with the little store and test feature. Okay? Back in the day, I taught fractions by doing 8 divided by 12. I'd press enter and they'd get this decimal. And then I learned a shortcut. I learned that you could press math and there was this fraction tool that would take any answer that you had and convert it to a fraction. Look at that. That 2/3 looks really pretty. Much better than how I typed it in. Math print is a relatively new feature on the 84 family. There is a one-stop shop for fractions, which is the Achilles heel of most Algebra 1 students. They struggle with fractions. Show them the green alpha key followed by the y equals. On all 84 models that have been updated to the latest operating system, you'll have stacked fractions, mixed numbers, improper fractions to mixed numbers, and vice versa, fractions to decimals, decimals to fractions. One-stop shopping for all your fraction needs. There's a beautiful template, much nicer than 8 divided by 12. And when you say divided by, that's where all the confusion lies. Is it a fraction? Is it a division problem, right? Okay, so I'll put 9 in the numerator, and I love that the cursor has a little icon of an arrow pointing to the right. I try to tell students to use the arrows. Do they listen? No. They'll just press the down arrow, and it goes to where they want on the fraction template. On future templates, it's much nicer to follow the arrows. I will put in something like 27. When I press enter, I see that it automatically simplified to 1/3. Kids love their scientific calculators, and you give them a graphing calculator and it's missing one particular button, the ABC fraction key. Alpha, y equals, option 2, 3, right arrow, 8, right arrow, 24. 3 and 8/24. If I press enter, it did a multiple representation. It wrote it as an improper fraction. Alpha y equals, option 3, we'll take that last answer, 10/3, rewrite it to 3 1/3. Alpha y equals, option 4, 3 1/3 is 3.3 repeating. I entered 3 and 8/24 and have seen 1, 2, 3 different representations for the same number. That's the power of math print. Alpha, followed by window, the second button going across the top. Here we have templates for absolute value, summation, numerical derivative, definite integrals, log of any base, x root, permutation, combination, and factorial. For Algebra 1, you're going to need that absolute value. When you select number 1, absolute value, again, I taught in days where ABS would show up on the screen and not this beautiful math template. And trying to get kids to use the math template when they write it down on the test and not write ABS because the calculator showed that was difficult. Kids, users, teachers, we all do this mistake. The negative key is by the enter button. It has parentheses. The minus button is in the operations over here. But your eye would catch them and they look the same. If I do the absolute value of minus 9 instead of negative 9 and press enter, uh-oh, I broke the calculator. I get this error message. You have two options, quit or go to. We are not quitters. Absolutely not. Nothing is going to ever make us quit. So we have to choose number 2, go to. Look at what it did. It put the cursor on the character that doesn't belong. That character doesn't belong. It shouldn't be a minus. It should be negative. I overwrote the minus with a negative and pressed enter. If I could go back to my teaching days, I would make more mistakes. Because kids need to see mistakes because then you know how to fix them. When I was in the front of the classroom, I just stood up there and showed all my math knowledge and got everything right, and it intimidated the kids. Be human. Make mistakes. Because then the kids know that it's okay to make mistakes and we can learn from them. If they got to the state exam, every single time they did absolute value, they used negative, negative, negative. But then they made a mistake and put in minus. They can't ask for help on something like this, and now they're discouraged. Teach them that common mistake. Alpha window. There's a lot of great features in here. Some for Algebra 2, some for Beyond. I'm going to move on to Alpha Zoom. Alpha Zoom is a shortcut for matrices, creating a matrix. Now, the only reason I would show this for an Algebra 1 is that systems of linear equations is a guaranteed question on all New York State Math Algebra 1 Regents exams. A system of linear equations has 2 rows and 3 columns. Let's make this practical. I'll find a system of linear equations question from a state exam. Okay, so this is January 2020, Algebra 1, question 20. Which system of equations has the same solution as the one below? So a student would have to solve this system of equations, and then this one, and this one, and this one, and possibly this one, until they found the same. How much time is it taking your students to do one of these? And this is for 2 points.
Oh my.
Yeah. So I would have the kids in my classroom go into this tool and select 2 rows, 3 columns. That's what this is. 2 rows, 3 columns. I just use my arrows to navigate. I press enter to select, and then I go down to the word OK and press enter. Now, it doesn't look exactly like the problem, but we can work our magic. We take the coefficients now. So 3 is my x coefficient, right arrow. -1 is my y coefficient, and the solution is 7. I'm going to go right back to it. The cursor is telling you how to navigate. Please press the right arrow. It's going to be much easier. 2, 3, 12. 2, 3, 12. And then I press enter. It doesn't do anything. It just recorded my system of equations. I would have my students go into the matrix menu. Second, matrix, which is that x to the -1. I right arrow to the math column, and I up arrow, and I see at the bottom of the list all this treasure. And who loves treasure? Pirates. And what do pirates say? Arr! That's what I would have my kids do to recall that the item in the math menu that has more R's than anything else, reduced row echelon form, RREF, when you put your system in there and press enter, you have your solution. X was the first column, Y was the second column, and the solution was on the far right. So if you read across the row, 1x and 0 y's is 3, x equals 3. 0x and 1 y is 2, y equals 2. 3, 2 is my solution. Now that does sound like a lot of work that we just did, but if you sprinkle this in the appropriate way in the classroom after you've mastered paper and pen, this is going to be such a time saver for something like this. So, second, matrix, math, reduced row echelon form, alpha, zoom. I want a 2 by 3 matrix, and I could then go right through the answers. 18, -6, 42. 4, 6, 24. Same solution set. I could have gone through 1, 3, and 4 as well, and you would have seen different solutions. This is going to be on the state exam. If it's a part 2, 3, or 4, and they have to show work, great. The kids at least have a fighting chance because they know what they should come out with. But 9 times out of 10, it's a part 1. Use the technology to the full advantage. Let's go to y equals, and I see in my y equals page all my y functions where I can put something in. I'm going to put in a linear function. 2x plus 3. I want to get back to that calculation screen, and I do see a quit above mode. This is the only time it's acceptable to quit. So if I press second mode, I'm back to my calculation screen. The reason I did that is I want now to go to alpha trace, a shortcut for all of your y functions. If I select y1, it appears on my screen. Open parentheses, 0, close parentheses. Press enter. My function was 2x plus 3. What the calculator just did was substitute in 0 for x and computed 2 times 0 plus 3 is 3. Up arrow twice, press enter, left arrow on top of the 0, replace the 0 with a 1. Repeat this process, and the students now are substituting in an x value, pressing enter, and computing their y value. They are making a choice. What x values do I want to use? I'm going by a step size of 1 for x. And my outputs increase every time by 2. This engages the user. I know for years I was guilty of this. I just went to the table. After I typed in a function, I would have the kids press second graph to access the table. These are the exact same values, but the students didn't do anything. So these don't really have any meaning. To do it over again, I would have the kids do it this way to create their XY function table. Because now they have to earn it. They're doing something for it. I go back to y equals. I go down to y2. And I put in x squared. I'm going to quit out of this second mode. Clear my screen. Alpha trace. Select y1. Open parentheses. Alpha trace. Select y2. Open parentheses. And now I can put in a numerical value. 5. 5 squared is 25. 2 times 25 is 50. Plus 3 is 53. That's composition of functions, which does sometimes show up, transformations, compositions, on an Algebra 1 exam. More prevalent on Algebra 2, but composition of functions is now a reality with putting in the functions into the Y editor and alpha trace to access the shortcut. I think that's really neat. Let's go to y equals. Let's clear out what's in y1 and y2. Now, this is the time where I'm glad people are sitting down, because what I'm about to show you is great for New York State Algebra 1. And it's only on the TI 84 Plus CE. If you are in Y1 and you press the math button once, and you press the up arrow twice, piecewise templates is there. Now, if you're watching this and you do not have piecewise after you press math once and the up arrow twice, your operating system needs to be updated. And I can definitely share a video on how to update operating systems. How this tool works. I'll select piecewise. It defaults to 3 pieces, but New York State Regents, it's usually only 2 pieces. So I'll left arrow once and select 2 pieces. I'll down arrow once and select OK. That is better than I could write it on the board. So, in our state exams, are there piecewise questions? Right there. Question 27 from that first exam we were looking at, June 2019. Question 27, absolute value of x for all values of x greater than or equal to -5 but less than 2, and -2x plus 10 for all values of x greater than or equal to 2 but less than or equal to 6. Watch this in action. So absolute value, alpha window, select number 1, x. The cursor is telling you how to navigate, so I'll press the right arrow until I'm in the restriction box. I'll type it in as I see it. -5. Now I have to get this inequality symbol, and I saw those earlier. If I press second math to access the test feature, here they are. But TI wanted to make this foolproof. There's a new menu on the 84 plus CEs called Conditions. I want this symbol, less than or equal to, and greater than or equal to, and less than. That's right here, option 7. It mirrors what the question had, and I need 2. Right arrow, -2x plus 10, right arrow, 2, second math, over to conditions, and I want, I believe, option 5 this time, and 6. Now, a great tip for distance learning is you never have the kids just hit graph, because you don't know who used it last and if they have the right window settings. So instead, I strongly encourage you to press zoom and then number 6 for standard. This way, you will not have kids saying, mine doesn't look like that. There's your piecewise function. If I needed to get the values to plot it, well, we've already gone to the home screen, and I've shown how you can put in a value here. So if I said I wanted to evaluate it at 0, I could get values that way. We could go to the table and get values that way. Or, second trace, there's a calc menu and a value feature. If I select number 1, I can now say what x value I want the corresponding y value for. -1, -2, -3. I want to know for -3. And it shows me -3's at 3 right there. The only thing that's really missing from my calculator and right here are these wonderful grid lines so I can count the boxes. The 84 plus CE has grid lines. Second, format. That's the zoom button to get to the format. Grid off is the default. Grid line is what we want. Now it is mirroring what the kids see on the assessment. It'd be great if I could just trace the function. Well, when I hit trace, I see 0, 0 wonderfully displayed. However, if you move off of 0, 0, it goes by the pixels on the screen and not by the values we would have our kids use. How can we fix that? We go to Mode. We scroll down to the word Full. We scroll over to Graph Table. This has been on the 83 plus, 84 plus for years. No one ever does it. It's under our noses. Select Graph Table. You get a multiple representation. Here's the table. Here's the graph. Put your cursor in the table. Second, graph. Now, when I hit up or down in the table, I can see where that coordinate is on the graph. Notice it jumped right to 2, 6 when I went when I moved. That, very cool stuff. What's nice about the 84 plus CE, if you make this change in your classroom, it will retain this. So if I go to y equals right now, clear out what's in here, and I just go back to something like 2x minus 1, and I hit graph, I'm going to get the table and the graph and the grid lines every single time. Students who struggle need this multiple representation. But they don't listen to us. They'll hit the trace key and look what happened to my table.
Oh no.
Don't hit trace. Quick fix. Just put your cursor in the table. Second graph. Notice, once you put your cursor in the table, it has a darker border. It fixes everything. Kids, we already said, struggle with fractions. What if the slope of our function was a fraction? Alpha y equals, choose the fraction template, 1/3 x plus 2. I go and graph this, and I see a beautiful display on the left, and a decent representation on the right. My students, I taught, you can't plot 4/3 of a box, 5/3 of a box. You would have them look for the nice, pretty numbers in Y1. Watch this. If I press second graph and I put my cursor in the table, and I happen to be resting on a pretty X and Y value, I can press the plus sign, and it allows me to change the X increment for the table. Because my denominator was 3, every third value looks pretty. I can replace the default 1 with a 3 and press enter. And now my table, without navigating away, is updated where the kids can actually see values that they would plot on the graph paper itself. Huge fan of turning on grid lines, splitting the screen for graph table view. Yes, you could play around with zoom and find it so that you could trace using this, but I find more times than not when kids play, something goes wrong. Since you said you are relatively new to the graphing calculator, you're going to need hints, tips, and tricks all the time. If you're in a menu, like math, and you go over to num, you see what looks like a bunch of syntax that doesn't make any sense. Yeah, I mean, you do know absolute value, but round. Rounding. How do I use the round tool? I don't know. If you're in a menu and you press the plus sign, catalog help is built in on all 84 plus CEs. It will show you how to use the tool. So you put in your number, 2.449, comma, how many decimal place values do you want to round to? Well, the first decimal place would be the 10th, and so on. So 1, 2, and so on. I want to round to the nearest 10th. Close parentheses. Paste is written above trace. I just typed it in with my instructions basically right there in front of me. So many kids can tell you. You look to the right of the number you're rounding. If it's a 5 or more, you round up. 4 or less, you round down. But don't you have kids that look a little bit further, and they see this 9. What would this 9 make this 4? A 5. What would that make this? I've seen kids talk themselves into 2.5. When I press enter, the math is solid. So again, that little feature, go to any menu feature, lowest common multiple. Your kids may struggle with fractions trying to find the lowest common multiple. Plus sign. How you use it's right there. I want the lowest common multiple of 6 and 9. Paste. Enter to execute. See, I was going to go with 54, but 18 is a much better number. Now, because we are doing distance learning and it's so tricky to be able to have kids follow along, sometimes you've got to make your own documents. So, since I have Word at my disposal, look at this cool feature. Click on the software screen, drag, and drop right into Word, PowerPoint, whatever application you're using that accepts screenshots. You can click, drag, and drop right from there so that kids can have a easy guide to follow through what you're doing. Every button that I've pressed for the last 50 minutes is going to show up down below now. So here's every single button. And if you wanted one, you could just click, drag, and drop it into your document as well. I don't want too much going on my screen at one time, so I turned that feature off by hitting the Hide Show key press history. There is so much you can do with the 84 Plus CE. I encourage you to go to my YouTube channel. Let me see if I can bring that up real quickly. So if you do a search for my name, Mr. Dana Morse, the YouTube channel since March, I believe, has over 60 videos. And you can take any topic that you saw in this video and break it down in just a 2 minutes, 3 minutes just on that. So solving systems of equations, things like that, the test feature, piecewise functions, all of these are in videos that are good for students' attention spans. 2 minutes, 3 minutes, nothing more than that. If you have any questions, feel free. But I'm going to post this video onto the YouTube channel. If you don't see a video here that you would like, email me at dmorse@ti.com, and I'd be happy to share it.